programs. And coming to this highlights of engineering NIE, it is NBA accredited almost till 2023, almost 3 times TechU funded, TechU phase 1, phase 2, phase 3, and almost we have, you name any department, those departments have center of excellence, and also we have a good research ambience at the Department of Mechanical Engineering. And we received a lot of funds, not only from TechUp, even from other funding agency, to a tune of around 700 lakhs already. And recently, for electrical engineering and electronic engineering related to this sustainable energy, so we received KFIST projects from Department of Science and Technology, worth of around 1 crore. So coming to my department at NIE, that is that almost BE in mechanical engineering started in the year 1958. Then this research center recognized by VTO in 2003, and we got this autonomous status in 2007. And later we have this 3 MTech programs. One is industrial automation and robotics, and we have good admissions at our institute, even though the admission is very poor, not only for master's degree, even for BE, but at NIE we are having more demand, and also we have almost full strength at UC level, whereas at MTech level, almost more than 70 or 80% of the seats were filled. So in addition, we have this MTech in machine design started in the year 2014. And also we have one more interdisciplinary program called MTech in nanotechnology that also started in the year 2014. So, and almost any institute should have a good understanding, that is memorandum understanding. So some of the premier institutes or research related institutions which are shown here, not only from academic, it is also from industry point of view. So in my department, maybe because of the work what I took at the during my research from almost 2000 to 2005 or 6, wherein I got the opportunity to carry out my research work at Central Power Research Institute, Bangalore, even though I got seat under QAP at PSC College of Technology affiliated to Anna University. So when I uh, visited this PST College of Technology, and the area of research what I identified is related to tribology, but at that time there were no facilities at PST Tech to carry out characterization or even fabrication of this whatever polymer based composites. So in that direction, so what I did, I made survey where these facilities are available, and also met professors at IASC and also IIT Chennai, and to some extent this IIT Delhi also, where some leading researchers worked for more than a decade who are in the area of tribology. So one is Madam Indumati Bijwe from IIT Delhi, and then in Central Power Research, Dr. Sitaramu and also Sampark Kumaran, and from Indian Institute of Technology, Surappa, and also one Professor Kishore. So they are into the polymer based composites. So maybe because of those contacts, and also I went through what facilities are there and they're having. So, and maybe when I took my this what is called coursework at PST College of Technology, so I thought of I should contribute at least more at towards the research society, so that it is beneficial not only for researchers, it should be for the students of the National Institute of Engineering. So during the coursework, I wrote a project for this DRDO, that is Aeronautic ARDB project. We got around 30 lakhs to this PhD College of Technology. And later at NIE, after completion of my PhD in 2007, so I also took some projects, and also because of TechView funding, we have these facilities at NIE. And my sincere request to all who want to make use of these facilities at NIE, especially for structural applications as well as for tribological applications, we have good facilities. One is this, what is called universal testing machine, wherein you can carry out metal matrix composites, polymer based composites, and even conventional materials. So one is this, what is called tensile testing as per standard. We have good fixture and also different load carrying capacity, load shells. Then you can also go for this, what is called shear testing. Then impact tests are not impact testing, it is flexural testing. So even interlaminar shear strength of polymer based layered composite, also you can conduct using this universal testing machine. It is computer interfaced, and the capacity of this machine is maximum 100 kilonewton. See, the unique advantage of this UTM is you can also conduct tests at room temperature and also at cryogenic temperature up to minus 30 degrees Celsius using nitrogen gas. For that, we have accessory or a chamber, so that that access chamber is filled with nitrogen, and we have PID controller to monitor what is the cryogenic temperature in that chamber. So instead of using nitrogen gas, you can also think of heating the chamber so that up to 300 degrees Celsius. So you can maintain the chamber temperature, so that even at elevated temperature for some of the composites, you can conduct tensile flexure as well as double shear or single shear. And also we have fixture for to carry out what is called the K1C property, that is fracture toughness of polymer based composites. So in addition to this machine, that is research related equipment, we also have a tabletop impact tester where it is also computer interfaced, that is adjacent to this first figure. So wherein you can carry out the notched and unnotched samples, you can conduct test for IZARD as well as Charpy. And also to prepare notch, we have a notch cutter accessory also along with this. So almost this is about the mechanical related properties. Coming to this physical properties of majority composites, we have what is called 0.1 milligram accuracy electronic weighing machine, and also density measuring kit following the Archimedes principle, wherein you can go through this what is called rule of mixture in composite materials. And finally, for the composite fabricated, you can carry out what is called the actual density or measured density of the samples. So that facility is also we are having at the Center for Composite Material Research at the Department of Mechanical Engineering, Mysore. So coming to this fabrication facilities, we have almost, we do almost composite fabricated by hand layup technique followed by compression molding. So that facility is available. In addition, for to avoid voids, we have this what is called almost this vacuum bagging facility, so that you can minimize the voids between the layers when you go for layup and go for the final composite preparation, especially this what are called the layer composites. So coming to the other area wherein it is almost heart of any mechanical engineering should know how the bearing properties can be evaluated. One is the wear studies, in that case, as per ASTM standard like G99, G76, G65, wherein you can conduct dry sand abrasion tester as per ASTM G65, erosion test using what is called air jet erosion testing with different tribo parameters, and also this more widely used for bearing characterization is what is called pin on disc machine as per ASTM J99. So we have almost these tribo equipments. One is adhesive wear characterization, another one is abrasive wear, and also one more is the erosion test. In addition to these facilities, we also have the wet erosion test as well as wet abrasion test. Those facilities are also available at NIF for characterization which are related to tribo. And nowadays we think of more of a bio-based lubricant. So in that direction, in TechUF phase 2, we procured this what is called the 4-ball tester, wherein for different bio oils and also for commercial oils at different temperature, what is the weld load, what is the wear scar, and also what is the coefficient of friction for non nano lubricants, and also for the as received oils, maybe bio oils or maybe for commercial oil. So it is also computer interfaced, and almost characterization of various liquid lubricants can be effectively taken up by using this instrument. Yeah. So these are the three equipments what I showed here. One refers to this air jet erosion testing. The next adjacent one is this what is called dry sand rubber wheel abrasion tester as per ASTM B65. And adjacent to that you have what is called the wet type abrasion test. Instead of silica sand which are dry, are made to flow through gravity by using hopper, so that you can control the flow of abrasives per minute. So that same abrasive particles of different size. So maybe with water you can make it a slurry, and if that wet type abrasion test can also be carried out. Similarly, for erosion, instead of dry sand, you can also make use of this what is called air jet erosion testing, wherein slurry is used as abrasive. And coming to this two-body abrasion, any abrasive uh, wear you can conduct in two, classify it into two different types. One is the two-body abrasion, the other one is three-body abrasion. So usually three-body abrasion will come under making removal of material from a cutting tool for the bar stock, maybe using lathe, that is an example. Whereas for bearing, if you take, you have what is called the sleeve. Around that you have lubricant, and then a rotating member made of very high strength material, steel. So in such cases, to evaluate what is the coefficient of friction and also wear, so you can think of this what is called two-body abrasion, maybe in two-body or three-body abrasion. It is in single pass condition. Every time the sample passes through the new path, wherein that counterpart is not very fine, having the high value of RA, where the emery paper of silicon carbide, or it may be alumina, those things, that means rough emery paper wherein the grid size, maybe rather than the particle size is on the higher side, so that wear loss is very high. So in those situations, you can think of conducting or evaluating the newer developed materials like composites using this what is called single pass two body abrasion testing. So almost all these equipments So maybe I have to thank this, what is called the one company in Bangalore, it is Magnum Engineers. So Dr. Govind Raju, he supported to develop these lab equipments at ANI. So with that, I thought of going for my talk. It is related to 3D printing for polymer composites in bearing applications. So already Suresh Kumar gave the almost the resume of mine in detail. If maybe you can see that. So this is my mail ID. So if anyone is interested in discussion, or also if you have any queries about the usage of lab equipment, so maybe you can mail so that you can make use of these facilities to the maximum extent. So coming to my plan of presentation, I will start with introduction, materials and fabrication, and two or three case studies I will discuss how to go about experiments, and also those results, what are the discussions related to that, and finally, what are the applications of these composites, and finally, I will go for this conclusion. See why I took, even though the title it is 3D printing of polymeric composites for bearing application. So majority this what are called audience, maybe faculty. So maybe they are in the beginning of research, or maybe they are concentrating more on academics, and some faculty members may not be aware of this fundamental. So without fundamentals on composites, straight away you cannot go for this, what is called this latest manufacturing technique called 3D printing for development of polymer based components. So because of that, I have made this plan of presentation, almost overview of this polymeric composites. Then I will go through discussions on how metal composites are fabricated, and later how to go about this characterization from following ASTM standards, then results as well as discussion. So coming to this slide, why I showed this images here is so you can understand a lot from these four figures. So maybe if you look at old technology, or the development of materials, almost say it is in almost 19th century, and maybe in that you can see these transportation vehicles or automotive vehicles, and maybe you see the whole structure or assembly of a four-wheeler. So this is what that photograph I took, and maybe from that you can understand the performance and also the materials used for the assembly, and also the aesthetic aspects. In addition, the what are called this corrosion aspects of these conventional materials usage, and also the total weight. So maybe because of this material science advancement, and also whatever technology we have today for fabrication of not only conventional material, it is related to what are called man-made materials, and also this usage of computers or softwares. So how the advancement takes place, and maybe because of those advancement, nowadays almost all we use this the latest car, and maybe you see the performance, not only performance, aesthetic aspects, and also the total weight, and also this almost materials what we use. Almost you can go for even corrosion resistant, very good corrosion resistance materials. And coming to this one more, where it is used as a windmill in earlier 19th century, and maybe you see that huge structure, and also the components or assembly of that tunnel, or what you can say, that turbine, wind mill, you can say. And also you see that area or surface occupied by this. So, and also efficiency of that. And nowadays, maybe because of this technology, and also the companies where they are into this development of windmills for power generation. I think everyone, you can visualize these things at near hill areas. So where the size and also materials what we use, so it is almost you can imagine, or just think in that direction and see how material development takes place. And because of that, and also this industry 4.0, so we have this latest products. So why only in transportation or in power sector? Why even in structural applications also? You can think of using what are called this waste materials. Whenever you go for cutting different woods, you will have a lot of waste. Why can't you make use of that sawdust and develop the waste materials into a products which are for various structural applications? So maybe in that direction, at wood plastic institutes in Bangalore, so you have what are called the composites, wherein that waste material related to wood are converted into various products. So from these images, you will be aware of how that waste material can be effectively utilized to produce the products, especially for interior decoration, doors, even for walls of the offices can be decorated with these products. And one more view or utilization of this waste is given in this figure. And also some of the sandwich composites and also waste materials, wherein you can access the insulated materials. And nowadays a lot of research is going on just related to this soundproofing, in especially this what are called the auditoriums, by using what are this man-made materials, wherein you are going to utilize almost natural fiber with very lightweight and foam type structures for roof soundproofing applications. So the benefit of the composites, not in one direction or for a particular application, it is multi-directional. So maybe in that case, almost if you make use of this polymer-based composites, you need not go for painting of those parts. So almost a natural colorant you can think, and during fabrication itself you can add those pigments and develop the products. So maybe from that, because of density, it is very, very less. Because of that, you can say the performance of the composite when compared to any conventional material, because of high dense materials, here the benefit is very high strength to the weight ratio. That is an added advantage when you think of these what are called the polymer lightweight metal based composites for end applications. So some more applications of composites are shown in this figure. So not only in those fields, even in using natural composite, natural fiber reinforced composite, the post office box, and also helmets and roofing of almost what are called is parking area, where with economy you can build structures using these waste materials converted into composites and lightweight also. So even automotive applications are in the transport vehicles or even in chairs and other moving equipment, you can think of these polymer based or polymer filled with metals, so that their access bearings, rollers, etc. So can be effectively and already we can utilize these composites for the applications. And if you look at these, why I took this figure here is, so as I said, nowadays we have industry 1.0, 2.0, 3.0. Now it is almost 4.0 and moving towards 5.0. So maybe if you look at these metallic components and also some components which are made of polymer, and how complicated shapes and also thin sections like gears, this what are called the bevel gears, and also the structure complexity is more involved. So maybe because of the technology or because of this industry 4.0, if you look at that framework, we have this what is called digitized technology, digital printing, or what we can say 3D printing of both polymer based composites as well as metal based materials. So because of the technology what we have today, so with the minimum waste you can think of developing these materials to the very high accuracy and good surface finish. So some of the bearing components, again, I took almost all these things from Google searching images, and maybe from these four slides, you can visualize how the polymer composites with micro size, nano size fillers, so that they are nanoparticles or microparticles with fibrous reinforcement, maybe synthetic fibers or the natural fibers based on the design and also the selection of materials with whether it is thermoset polymer or thermoplastic polymers with the existing fabrication facilities. So almost all industries develop these types of bearings for various sectors. So some more figures, maybe you can say this polymer bearing technology from SKF. So this what are called ball bearings. It may be single row or double row. So except that what we call it as the balls or rollers or needles, almost all other parts of the anti-friction bearings, inner race, outer race, and also cage, etc. They are almost all made of polymeric composites rather than the conventional material. So maybe because of this advancement and also the performance wise, it is far better than the earlier bearings what we used for various application and also long life. So those are all the advantages. And when you make use of these polymers as one of the ingredient to develop products, best advantage what you have is one is lightweight. In addition, it is corrosion resistance. And further, when you think of this reduction of coefficient of friction, that is very much essential so that you can reduce power loss due to friction in various machinery. So maybe in that direction, the polymer is the best material wherein it acts as a continuous phase in composite. So like polytetrafluoroethylene, polyether ether ketone, epoxy, and also polyester, etc. So are effectively used in the development of bearing products so that you can reduce friction and also increase the wear resistance. Those are the benefits. And because of these newer uh, advanced materials for the development of bearing, so maybe you can think of the cost reduction in these products because of large usage, so that you can see in the present scenario. So some more components wherein the polymeric materials with various strengthening materials or agents are used to develop the composite materials. So some more figures, it is needle bearing, and maybe some figures which are here, sleeves, and also what are called the washers, or what you can say sealing parts. And also this, maybe you can see some cylindrical sleeve with contours, other things, without much wastage, because of thanks to this advanced manufacturing technology what we have. So with the minimum waste you can produce in one shot the final product. No secondary machining operations are involved when you go for development of these complicated shapes. And why only in automotive? You can see the applications in the electronic industries, and also this what we call biomedical or medical industries. So almost those applications are given here. And maybe if you look at this first figure, so if you refer this bigger one, what is the size and also performance. And nowadays we have this what are called the very smartphones existing today. It is because of the newer materials, and also this evolution of bicycle. And maybe you can see this old version TV with the latest one, and maybe the performance and other aspects if you compare. So maybe from these various slides you can think of what is the development, especially in materials technology, for production of components in the present scenario. And not only in those sectors, even in aerospace sector. So we have this ALH aircraft, where almost more than 40% of the components which are made of polymer based composites in aerospace also. So knowing those various applications of these newer materials because of the newer manufacturing methods, so just I will go through this overview of what is a composite material. So maybe if you refer already with the examples what I showed, so many engineering applications which require unusual combination of properties. So those properties you cannot make by selecting a conventional material. So for example, if you take aerospace, underwater, or even transportation, you cannot achieve with a single material, because any aerospace component it should be very strong, stiff, lightweight, and also abrasion resistance. But when you think of a material with these properties, it should be very strong and stiff, but materials are available with the higher density, and also the space occupied is more. So maybe you can think of some conventional materials. But if you go by lightweight materials and improve the properties so that it is man-made, and also they are abrasion resistant, so those are the materials which are not readily available as single materials or homogeneous materials. So in those situations, you need to go by this development of newer materials, what we call it as man-made materials, or simply a composite material. So what is this composite material then? So maybe if you refer the two phases, at least you need one continuous phase and one discontinuous phase to form an integral part for any end application. So in such cases, what is that continuous phase? So maybe you can think of, as I suggested earlier, you should be light in weight. You can think of aluminum alloys, copper alloys, etc. Whereas coming to this polymer based, you can either go for thermoset or thermoplastic materials where the density is very, very less. So, and also you look at that ease of fabrication. So maybe if you have a furnace of around 1500 degrees Celsius, so that you can melt what is called this aluminum alloy. It is around 700 degrees Celsius, and maybe by following the standard procedure of fabrication of metal matrix composites with suitable what are called the graphite uh, things you can select and go for the castings. So if you go for these polymers, almost all thermoset materials which are cured by using what is called polymerization. For that you need what are called the hardeners. It are almost amine-based agents so that polymerization takes place for the resin. So almost at room temperature or even at higher temperature or even using autoclave, you can cure those final consolidations. That facility already we have and it is utilized for development of various AI products. So why what I want to stress here is if you take polymer or metal, so lightweight and also easy to fabricate if you have those constraints, but properties are not very lucrative. That means it is beneficial. So in that case, you can think of this what is called nature has given lot of materials available like silicon carbide, alumina, fly ash, wherein you have this cenosphere, boron carbide, so many ceramic materials are available. So why can't you think of utilization of those materials, even this carbon fiber, glass fiber, aramid fibers, and nature has given lot of what are called trees and plants, wherein you can extract fibers from those trees or even plants and utilize those fibrous material so that it is having better load carrying capacity along the length of the fiber. So make use of those inherent properties of very high strength materials like fibrous materials or organic or inorganic fillers, so that with compatibility you can or you can go for surface modification and go for the development or to enhance the strength of either the aluminum alloy or the epoxy or other thermoplastic or thermoset materials which are used as continuous. So the just now what I told those materials like fibrous material or the organic or inorganic fillers. So those materials we call it as the functional materials, or you can say in appropriate composite terminology it is called reinforcement. And maybe in one of the slide why we have to go for very fine particles so that that particle size is almost spherical or even having flat platelet structure with nano size, one of the dimension. Why those fillers are used in the development of composite, what benefits maybe in one of the slide you will understand. So just for a layman, you can understand how composites can be fabricated. So maybe here you can see I have what is called this mat type structure, what we call that this carbon fiber fabric. So these fabrics of different layers, depending on how much thickness you need, with what is called this epoxy and hardener. So you can lay up and it is possible to produce this what are called the carbon fiber reinforced epoxy composites. And maybe if you go through this what are called, we call it as in composite terminology, laminates. So depending on orientation of the fibers, so you can think of the directional properties, how it can be improved. So almost nowadays we have this what are called smart materials, then we have functionally graded materials, maybe because of these ingredients and also different materials available with various fabrication facilities. It is possible to go for what is called effective design and fabrication so that minimum material waste can be taken care by using these various materials available in nature or even in the developed form. So from that you can say composite is a combination or aggregate of two or more distinct constituents. So scientific definition is this composite is a synthetic assembly of at least two macro constituents which are insoluble with each other and are chemically distinct on a macro scale, but nevertheless act in concert where to yield superior properties. Almost all composites, except this wood or even this what is called tooth, they are all man-made composites. So in this direction, when you go for more than two constituents to develop a composite, so you can call it as that composite as advanced composite, or even what we call it as the multi-phase composite or hybrid composite. So with that, I think I will go through already I have given what is matrix, what is reinforcement. So this matrix holds them in place. That is why it should be a continuous in the discontinuous phase, that is the reinforcement. So majority thermoplastic materials are available in granule form, and you know the difference, fundamental difference between thermoset and thermoplastic. So you need some device so that you have to heat these granules so that it will be in melt state. So in that stage, you have to add reinforcement and mix very well so that dispersion is more uniform. That discontinuous phase may be fibers or fillers, and finally you can make use of molds similar to this hot chamber die casting or cold chamber die casting to produce various parts. Whereas that is not so in case of thermoplastic composites. As I said, polymerization is required for the thermoplastic material, thermoset materials like epoxy, vinyl ester, or polyester. So maybe if you go through some little effort with some basic textbooks, easily you can produce or go for development of this either thermoplastic or thermoset based composites. So various fibers, starting from natural fiber up to synthetic fibers. So some even nowadays in some of the applications wherein you need to strengthen the materials in Z direction rather than X and Y. So instead of selecting 2D fabric, you can also think of 3D fabric, three-dimensional fabric as effective reinforcement to develop various composites. So why only synthetic fibers? You can think of this coconut tree. So you take any part of that, it is having what is called the cellulosic material, what we call it as natural fibers. Why can't you make use of this readily available, maybe with what we call it as some surface treatment is required so that you remove that unwanted material like pectin from the fibrous material and make use these bio-friendly materials as effective reinforcement to produce biocomposites for various applications. So a lot of research work is also going on with respect to this, and even this Brazil and also this what is called the Malaysia. So these countries almost all the synthetic composites they are thinking of replacing with this bio-based composites, and even for farmers they are encouraging to develop this fibrous plants or even trees, and almost government is almost supporting for the farmers to grow these types of naturally available this what are called trees or plants, and finally make use of those fibrous materials for development of products for various applications, especially for transport. And as I said, alloy is different from a composite. If you take this composite materials when it is fully cured with high-end microscopy like scanning electron microscope or transmission electron microscope, wherein you want to visualize how the nanoparticles are dispersed within the continuous phase, that is matrix material or even fibrous materials like glass, carbon, how they are oriented, how that bond between matrix and fibers are there in the integral part of the component what you made, even if it's a platelet structure like this granite or other particles at micron size or nano size, whiskers which are dispersed and bonded well with the polymers or other metallic materials. So those interfacial aspects and also dispersion aspects of the composites can be studied by making use of what is called the transmission electron microscope or even scanning electron microscope. Especially TEM is very costly, so maybe that is usually a good facility for characterization of nanomaterials other than micro composites. So as I said, in some cases you have already, as a designer, you have selected materials, but sometimes you will end up with bonding or adhesion problem with the other constituents during fabrication. So maybe in such cases, you can think of the additives like plasticizer or a filler or stabilizers or flame retardants, coolants, colorants, pigments, etc. to modify the properties of either the matrix material or the reinforcement material. So this is the slide where you can visualize how these nanoparticles are beneficial in the development of nanocomposites with very low volume like 0.5% carbon nanotubes will give optimized properties, whereas to achieve the same strength for the two phases where if you use carbon fiber, you may need to go for 68% of carbon fibers to get the same properties. So maybe any organic filler or inorganic filler, particles shapes are different. So some particles are having like a sphere, some particles may be like what are called the flake two-dimensional structure, or other one like carbon nanotubes, maybe one-dimensional structure. And maybe from these three rectangles, figure A, B, C, so maybe if you refer that I have selected three particles of weight equal to W, where the each diameter is 100 microns. And this is the area, 50 micron by 100 micron. If I want to disperse those particles, so one theme, what I have shown here, it looks like this, almost 2.5 particles are within that surface. So this is not a good dispersion and will not give good properties, even though it is a micro composite. But look at this second one. I have taken that same weight, three particles only, crush it further by using ball milling so that you have more number of particles and particle size gets reduced. Instead of 100 microns, that is 10 micron, each particle here is 1 micron. That means almost you have 300 particles from those three 10 micron diameter particles. So if you take those particles, weight remains same, volume is increased. So if you disperse those within that same area, so this will give better load carrying capacity. So the strength of that plate will get enhanced, and also not only strength, modulus also will get enhanced. So instead of ductility, the brittleness is increased for this. So whereas that same particles around 2860 micron particles of 1 micron. So if you further go for synthesis of those particles so that each particle after synthesis, it is one particle is at nano level like 100 nanometer. So in that case, see the number of particles and same weight only what you took for A, B or C, but you look at because of the reduction in size from micro to nano. And if you take those particles, 2 lakhs 28, 2 lakhs 86,000, that is particles, and disperse in the surface area effectively so that there won't be any agglomeration. So maybe this is why we go for talk about more of nanotechnology rather than micro for development of various products. So some more polymer composites, how they are manufactured is given. So for better efficiency or the good product, you may go for this what is called vacuum bagging. So that is what is shown here. So then coming to this polymer matrix composites, either you can think of thermoset or thermoplastic polymers with majority synthetic polymers, carbon fiber, glass fiber, aramid fiber, basalt fiber, boron fiber, etc. And what are the benefits instead of metals or ceramics as the base material or continuous material? If you select a polymer as the base material like matrix with various organic fillers or inorganic materials, you can think of in fiber form or the particulate form. What are the benefits? One is high strength to weight ratio, lightweight, fire resistance, good electrical properties, so chemical properties, weathering resistance, color, any pigment you can use and get the natural colors. Maybe because of this, in wood-based composites, you can see even that teak structure can be get from this man-made what are called doors or frames, even the window frames, etc. So that is the technology available today. Translucency, then design flexibility, thermal conductivity is low for these components. Then manufacturing economy. Maybe if you go for the mass production, like definitely you have lower the cost for the product what you develop. So when you think of development of polymeric composites, it is for enhancement of mechanical properties. So you should be very, very careful when you go for what design considerations you should account when you go for selection of fibrous reinforcement. First, you should know what the type of fiber reinforcement, whether it is carbon fiber, glass fiber, and how much percentage of fiber or volume. That is very, very important. You cannot go for 100%. It should be, as I said earlier, 60% maybe maximum if you use hand layup, or you can think of pultrusion or filament winding. So up to 80% fiber you can impregnate with the polymer for the development of the products. As I suggested in classical lamination theory, for the laminates what you develop, especially the fabric reinforced composites, orientation of fiber is very, very important. So you can orient all fibers in X direction or in Y direction, or it is possible to orient from 0 to 90 or from 90 to 0, that combination. And what type of resin, really it is having good inherent properties. Is it an effective matrix material for the reinforcement what you selected? So unnecessarily you should not make use of very high strength material if the design requirement are not required. So in such cases, we should think of what is the type of fiber and what is the type of resin, so that you can have control over the cost of the product what you develop. Then how many products you produce, that is also very, very important, because more tooling is required, and maybe in that case volume of production is another important factor you have to consider. Then what fabrication process you follow, what service conditions that product finally may be. So those aspects you have to go in depth before selection of either reinforcement or the organic filler or inorganic filler, so that you can develop multi-phase composite with either thermoset or thermoplastic composite. So as I said, in classical lamination theory, orientation of each fiber is very, very important. So that schematic diagram I have shown with different layers. So in a composite, based on the bending properties required for the laminate, so you can think of the various architecture of fibers, so the stacking sequence differ. So because of time, I will not go through these slides because I have another 30 minutes, even less than 30 minutes. So I will quickly go through these slides. So you can think of the estimation of the development of composite before actually going for fabrication. So in such cases, you can think of this a chapter in any composite materials will give rule of mixture, so that you can study for ideal properties of the reinforcement and matrix selected. You can estimate what is the strength, what is the density, what are the thermal properties, what are its electrical properties. Based on some of the researchers developed different models. So maybe if you have this fiber orientation, so that what is the stress induced, what is the strain, it is same. So similarly, one more model, it is where stress is constant, strain is varying, so that the orientation of fibers is in x direction, there in y direction, and loading is different. Similarly, the difference between this Reusch model and White model, and how that property evaluation with respect to modulus with varying weight percentage of reinforcement are given here. So for the matrix material and for the reinforcement material, almost reinforcement is having very high strength but lower strain, whereas epoxy or any matrix material will have better ductility rather than strength. So superimposing these things, you will get combined properties where it is not homogeneous material, it is heterogeneous materials. So other properties like shear modulus, Poisson's ratio, thermal expansion. So you take any property, so you can model it and try to estimate that, and later only you go for procurement of those materials with proper from best suppliers, because in market people will also cheat. Just it is money is involved there. So try to make more survey and get a good the confluence for the development of research work. So some equations are given here, and maybe coming to this industry 1.0, wherein mechanization, water power, steam power are given more importance. In second, mass production, assembly line, electricity. Then you have computer and automated in industry 3.0, and now we have this what is called cyber physical systems, wherein this framework consists of Internet of Things, smart sensors, advanced robots, big data analytics, and in that, this 3D printing is one more very, very important technology with respect to the manufacturing. So, if we make use of this 3D printing, or what we call it as rapid prototyping or 3D additive manufacturing, for the development of composites, especially polymer composites, how those polymer composites perform. So those things I will go through from these slides onwards. So some of the complicated components made of polymeric based composites, these are all developed using what is called 3D printing. And maybe from these components, even though it's a multi-cylinder block for this what are called the automotive vehicles, in one shot, it is possible by using what is called the CAD model with STL file. So you can reproduce using the raw materials what you select by using a proper 3D printer. So no secondary operations are involved, and maybe visualize the application or importance of 3D printing in the present scenario, maybe by looking at these products, which are all produced from 3D printing, not from the casting and then machining, etc. All those things are totally eliminated. So maybe because of the technology what we have today, so why can't we make use of this advanced technology for mass production, so that cost of per product can be reduced. So some more components which are very, very thin and also very complex. Those components easily you can produce by means of this what is called 3D printing. So then this area of 3D printing, what are the benefits? So it is possible to go for cheap manufacturing if you go by mass production. So quick production is there, less waste, accessibility, then sustainability and new shapes and structures. So these are the benefits of 3D printing. So coming to this 3D printing applications in various sectors which are given here, I will not go through in depth. And maybe the usage of composites with 3D printing worldwide data are given here. From one is this company called JCE Composite develops components for transport 35%, for industry it's 10%, electrical and electronics 14%, sporting goods 10%, and also around major share goes to this construction related industries 31%. So this is where the composites can be manufactured. I will not go through. So you have sheet molding, injection molding, resin transfer molding, pre-preg, pultrusion, filament widening, thermal spray. Then how that different stages are involved in the development of thermoset polymer composites, starting from selection of materials up to the curing that are given here. Anyhow, I will share this whole PPT for you so that you can also go through those who are interested. So coming to the simple hand layup technique for researchers, this is more useful. And hand layup for a product, how you can take up for the with the mold available. Then this pultrusion method of manufacturing, especially for UD fibers or fabric architecture with width minimum. So in such cases for mass production and also for better efficiency, better reinforcement, 70 or 80% you can think of this pultrusion technique. So some more figures are given with respect to that diagrams with respect to pultrusion. Then what are the various what are called components of this pultrusion, like rovings, mat, then you have impregnation with the resin bath, then preformed, what we call it that whole rovings are wet with this minimum quantity of resin, so that what we call it a preform. Then it is fed through molds with heating agents, etc. Then we have for better shaping the traction with rollers, and finally that whatever extruded pultruded part is taken for a different length for transportation. And some of the figures are shown here, and various complicated sections of different types can be produced by using this pultrusion technique. So then you have this, what is resin transfer molding. Then for almost cylindrical or pressure vessels, you can think of this what are called hollow sections using filament winding method. So some of the products which are manufactured using this filament winding is from the state-of-the-art composite tanker for transport of highly corrosive chemicals, which are shown here. And for our research, we use this development of multi-phase composites where nanomaterial is used as the one of the ingredient. So in such cases, you can make use of this sketch and available in our published papers. So this work is our joint work from University of California, not California, it is uh, mm, from USA, where we have this North Carolina University. So there with Kunigal Shivkumar, he is heading Center for Composite Material Division, where we use this what is called spinning of fibers. That means polyamide spinned, and it's at nano level, and those nano fabrics were layered between carbon with epoxy and developed a composite for study of friction as well as wear of these composites for some end applications. So how these properties, damage tolerance, impact for behavior, temperature resistance, electrical resistance, wherein what should be the proportionate of matrix and also fibers. So maybe you can understand from this slide. So coming to this 3D printing, already I told you have so many advantages, and it is an additive manufacturing process that creates three-dimensional objects for three-dimensional digital information. So this three-dimensional digital models are sliced so that you have what are called number of layers into in many two-dimensional cross sections that are then printed one on top of the other. So maybe if you look at this, it is similar to our what is called simple hand layer technique. So maybe to understand this printing technology better, so maybe I have taken one this what is called three-dimensional component, where you have number of slices, and later how those slices are formed with ingredients, polymer with the filler or fiber, using what is called 3D printer layer by layer. So it is shown from this. You have a model, slice it, then print it. So how easy to manufacture the final products of any complicated shape using 3D printer can be visualized from this slide. So look at this one more component, and how those different slices were made in CAD model and later fed to that through system, and then finally produce this component. How, so look at this aesthetic aspects and also the outer surface with so many cavities, other things, so that see that product, and it is with almost zero defect, you can develop this model or product by using what we call it as is 3D printing. So one of the 3D printer model here I have shown. So that 3D printer moves along three axis, X axis, Y axis, or Z axis. So controlling the quality of product depends on whether you go by orientation of printing in X direction, Y direction, or Z direction. So that properties also differ, and maybe from optimization point of view, you have to think whether you have to go by the printing direction in X or Y or Z, depending upon the material combination what you select for the development of a product. And maybe in our what we call today in structures, especially flyovers, you have seen the cast parts and then going for assembly. So same concept is there in 3D printing, and maybe this 3D printing exists for centuries. So if you look at this, how that Greek built column, look at Franco in 1806 works on photo sculpture, you can see the beginning of the idea. So this is one photograph of the maker boat replicator. So then so many printing parameters and technology or fundamentals are involved. So try to understand those fundamentals and go for this, whether you have to go by fused deposition modeling or fused filament printing or powder bed methods, etc. So this is depending upon fused deposition modeling, how that product is finally developed using 3D printer. So one more line diagram of this FDM is shown here for your reference. In powder bed, how those parts are manufactured are also given. So this is another product where the 3D printer uses to develop. This is one more product. And before going for this 3D printing, so you should go for solid versus mesh, solids versus mesh. In that you need to go for AutoCAD, SolidWorks, or 1, 2, 3D design, Tinker, CAD, etc. So many softwares are available. So you can make use of that and develop these CAD models. And finally, you can fed these things to the system. Then preparing your files for 3D printing, it should be .stl or OBJ format. Then some of the composites were 3D printed and their properties are shown here for your reference. And some more methods of manufacturing using 3D printing, and for what applications and what combination of materials you can select which type of method, state of the art of starting material with what process, whether it is FDM or robocasting or SLA or SLS, etc. So coming to this, what is called mechanical properties, maybe because of time I will not go through. So as per ASTM 309, this is the equipment what you can use. Alignment of the sample should be in the unidirection. Then how those tests are conducted, so that you will come to know what is the stress versus strain. So then how that failures, spectrography you can analyze. And then coming to this flexural testing, that is 3-point bend test and also short beam test for evaluation of internal avalanche shear strength. So you can go through this, what is called ASTM D790. So then after fracture, using SEM, you can study the how that fiber failures or particulate failures and what is the debonding, is there any voids, all those mechanisms or surface topography of the failed samples you can also examine using scanning electron microscope. And these are the 3D printed tensile and some components, and maybe you can see that tensile stress strength versus fiber loading and also modulus for the fiber reinforced composites which are given here. So with increase in fiber loading, you can see strength is also enhanced up to almost 40 weight percent. So maybe if you look at the 30 to 40 weight percent, almost strength enhancement or even modulus enhancement is slightly on higher side, whereas almost strength is optimized. So maybe 30 to 35, maybe 5% of fibers you can think of as the effective reinforcement with the epoxy material or ABS material for the development of composite for optimum properties using 3D printing. So some more details are given here, and this fly ash or cyanosphere with the high density polyethylene, where one work is from Dodmani from NIT Surathkal. He did this work and I took it from his paper, and he went through this what is called 3-point bend test and gave a lot of the inputs and also spectrography related to that HDPE based fly ash ionosphere samples or even glass beads also he took and published more number of papers. So some of the commercially available 3D printers are given for your reference. So then coming to this tribology of friction and wear are very, very important. So what are the mechanisms involved here? Sharing of asperities, surface fatigue and delamination. Then coming to this wear, how material is removed, all those things are available in the book. And as I said, any abrasive wear you can have it as 2-body abrasion and 3-body abrasion. For that, these illustrations are given here. And maybe for a tribose system with so many parameters, like what the input variables, distributed variables, then output variables, how complex it is for the system characterization sorry, can be visualized on this slide. What are the mechanisms involved are given here. Then when a hard particle like abrasive, like silicon carbide, moves with some velocity and also applied load, how material is removed from the bearing are given here, so that what is the type of mechanism involved? Is it cutting or fracture or fatigue by repeated flowing or grain out, grain pull out? All those things can be studied using the what we call it as a scanning electron microscope for the worn surface features. So the wear mechanism, when two bodies are in contact with moving velocity and applied load, how that material in the form of very fine debris get removed. So that can be visualized from this schematic diagram. So what factors you should account when you go for wear resistant components? So design criteria, that is transmission of load, type of motion, degrees of lubrication, temperature as well as environment, then operating conditions, speed, contact area, etc., pressure, abrasive characteristics, material properties, hardness, microstructure, work hardening ability and resistance to corrosion. So choice of material selection is given in this. And coming to this abrasive wear, it is dominated by what is the composite material combination, how, what are the type of relative motions, what wear mechanisms, what is the counter body, and what are the test parameters. So these 5 parameters you should account, so that you can study the abrasive wear performance in detail. So coming to this fabrication, so many methods are available. So in our research work, we followed these things, and some of the materials what we formulated is carbon epoxy with 48% epoxy and 68% carbon. Then we added secondary, that is three-phase composite, by adding 2 weight percent of fly ash spheres, 4 weight percent and 6 weight percent. And we followed this simple compression molding with hand layer procedure for fabrication. And we studied this pin on disc wear test, then also two body where it is in multi-pass condition. And these are the multi-pass condition abrasive papers with silicon carbide grit were used with 150 grit and 320 grit for evaluation of specific wear rate as well as coefficient of friction for the fly ash ionosphere carbon epoxy composites. And these are the results for that. Maybe you can see specific wear rate decreases with the breeding distance for different grit. As the grid size increases, the wear loss, the specific wear rate decreases. That is what is we can infer from these two graphs. And at higher load, also given the specific wear was upgrading distance for the composites what we studied. So as I said, why? What is the reason? You can attribute better in the results and discussion of any good quality journal paper by making use of this what are called the scanning electron micrographs of the worn surfaces at different test conditions, like with increasing velocity, with increasing abrading distance, increasing load. For the material system what you took, you can compare what are the mechanisms involved or how material is removed, which parameter affect the higher wear rate or lower wear rate. Those things you can effectively discuss making use of this what is called additional photographs, what we call it a scanning electron microscope. So these are all the conclusions related to this. Anyhow, because of time, I will not go through. And as I said, joint work from North Carolina University. This is the work carbon epoxy with nylon as the interleave with nano level layers were taken for the study. So this is how the composites were fabricated, where tests were conducted. So this is single pass condition wear test what we studied for these materials. And as I said, these facilities are available to know what is the density, and also for exact weight loss measurement. We have zero 0.1 milligram accuracy weighing machine with density measuring kit. And for hardness, majority thermoset or thermoplastic polymer composites, you can think of either Barkol hardness or Shore hardness. So this is that three-body abrasive wear tester as per ASTM G65 standard, and various parameters are accounted here, and these are the results and finally conclusions. So coming to the applications of the engineering composites, you can see in aerospace, you can see in shipbuilding industry, electronic industry, automotive industry, power sector, then various parts of where this natural fiber reinforced composites are used, etc. So then electronic industry, PCB, printed circuit boards, then in structural or interior decoration, etc. And these are our selected papers, recent papers in journals I have given for your reference. And finally, I will say, uh, make use of these, especially synthetic polymers. So we are cautious wherever it is necessary, you make use. Otherwise, disposal is a major problem. Or nowadays we have this what is called biopolymers. So make use of those polymers and attain the environmental restrictions so that pollution can be controlled. So with this, I will end my talk, and I should thank the faculty members, or what I can say, audience, for your patient hearing of my talk. And now maybe I will take 5 minutes for discussion of the topic what I discussed so far. So over to Nanesh.
Now we are at the end of the session 12 of FTP. I express my heartfelt gratitude to the speakers, Dr. Suresha B, for engaging this session and giving insight on 3D printing for polymer composite pairing. Thank you for your valuable time and patience, sir. Now I would like to call upon the questions to be asked by the participant, if any, can be posted in the chat box, or you can unmute yourself and kindly ask the questions.
You can unmute yourself. Any questions, you can share it in the chat box, or you can directly ask the questions.
So if there are no questions, so okay, I have given my mail ID also. Those who are interested, because later I will share the PPT also for your reference. So those who are interested in especially research related to tribology, so they can also interact following that mail ID what I have given. Yes. Any questions from the audience?
Hello, sir. Hello.
Yeah.
Yes, sir. I am Srikant Patil.
Okay.
Yes, sir, regarding composite material testing of compression after impact test, you have any idea about compression after impact test regarding compression strength? We need to find out for the respected composite plate. Do you have any facilities, sir, nearby your college?
See, is it for metal matrix composites or is it for polymer based composites?
Okay, sir.
No, the material, which material?
Yeah, that is a glass composite fiber, sir. Compression after
What
impact.
you do is you can go for the block as per ASTM standard. So almost
Okay,
one of the dimension should be double for compression test. So
Okay,
what
sir.
you do is instead of up to failure, you don't go for up to failure of the test under compression.
Okay, sir. Okay.
So that actually you are damaged.
Yes, sir. Yes, sir.
So that sample you can go for later impact.
Okay. First, we need to
You
go
are
for
not
compression.
conducting as received sample for impact test.
Yes, sir. Yes, sir. Yes, sir.
After, yeah, we have that facility. Only thing is when you do compression, the
Okay,
size
sir.
required is around 10 mm diameter, 20 mm or 18 mm length.
Okay, sir.
In that case, that size may not be compatible for impact test.
Okay, okay. We need to do different.
Dimensions are different. So what
Okay.
you should do, you have to make use of changes in the dimensions of impact test. You take
Okay.
that block as reference. That is around
Okay.
60 mm with
Yes.
proper thickness, so that you have maintained that two-dimensional ratio, so that that sample is compatible for both
Okay.
compression test as well as for the impact test.
Impact test. Okay.
Like
sir,
that
okay.
you have to prepare the mold and prepare the sample.
Yes, sir. That one I have doubts, sir. Thank you, sir. I will check it out. I will collect the mail, and
It is
if I have
available.
any doubts,
We can do
Okay.
in our lab that time.
Okay. Thank you,
It's
sir. Thank
a
you.
good idea.
Yeah. Sir, that kindly share the PPT so I can help. If
Sure,
anything is there, I will
definitely,
mail.
definitely.
Yes, sir. Thank you, sir. Thank you so much. Okay.
Sir, there is one more question which is posted in the chat bar.
Please go ahead.
How to evaluate COF in PMC?
Coefficient of friction. Is it coefficient of friction?
Yes, I think so, sir. COF in PMC. In PMC, polymer matrix
in polymer composites, see, it depends on what type of machine you are using. Let us say it's as per ASTM G99, wherein you will have the counterface made out of this EN32 steel with roughness of around 0.5 microns. So against that counterface, you are using the sample polymer-based composites with what is the load and also what is the sliding velocity and for how much time you will split it. So maybe if you look at that assembly of pin on disk machine with the measuring devices which were there, so directly you can record what is called the frictional force. Even Ducom and also this Magnum engineers, they have computer interface. They have software. Windowcom or this Magnum engineers having the separate software. So you can use and record what is the microns wear loss versus time. Similarly, what is the frictional force versus the time. So later from that digitized value, what is the frictional force? Frictional force to the normal reaction. So that ratio will give what is called coefficient of friction that you have to calculate. So you have to note down from the equipment that is from the what is called digital instrument that record is visible. What is the friction force developed for the set of tribo conditions imposed for the conduction of test. So you take that value and already you know what is the normal load applied. One of the test parameter is applied load. So divide that frictional force divided by the normal force. That ratio will give what is called coefficient of friction. Mu is equal to F times R. That is the relation, sir. Simple. F equal to mu times R. Yes, any other questions?
Thank you, sir. I hope I think you are clear that.
Yeah. Okay, because of I have some other assignment
Yes,
to conduct one BOS meeting, so at 11:30. So maybe if you have any specific questions or even discussion with respect to research related to polymer-based composite, always I encourage faculty members carrying out research in that area. So I have given my email sureshabhi at the nia.ac.in @ So kindly you send your queries or if you want to discuss, you can also call through phone. It's not a problem. Okay, sir.
Thank you, Suresh sir.
Thank
I
you.
would like to thank all the participants who have joined the live session.
Suresh
I
sir,
request all the participants to
It's okay.
fill the feedback form
Suresh sir.
for this session
okay, it's
shared
okay.
in the chat box. Hello?
Suresh sir, 1 minute. The principal sir will need to interact with the resource person.
Okay, sir.
Sure,
Okay.
sure.
Okay, carry on, sir.
Dr. Suresh sir, I'm extremely
Good
happy.
morning, good morning, sir. Good
Very
morning.
good morning, sir. Very good morning.
Good morning.
Sir, I'm extremely happy. The presentation was an excellent, and there are no questions. Means it's understood. Every participant has understood 100%.
Or they have not followed.
No. We'll take the positive way, sir, because the interaction was there. That means they understood 100%,
Okay.
and we'll have a long-term relations.
Sure, sir. Sure, no doubt in that.
And actually, some of the faculties members are doing the PhD works on this on your topic which you have presented today.
Yeah.
So hope in future we'll interact with you, sir. So we'll want your support, okay, online and offline also.
No problem, sir. Always I am, especially I know when I did my research work at various institutes, I came to know how facilities are not easily accessible in many of the cases.
Exactly.
So that because of that problem, always I encourage research scholars make use of these facilities what we have at our institute. So it is not at all a problem, and maybe because of that long relationship with even with B students also, I am publishing papers.
Very good.
I am encouraging, and one group of students made real attempt in getting that patent also with respect to hip joint replacement using polymeric composites.
Great work, sir. Great work.
Because of group teamwork and also with little what we call it as relationship with NITs, IITs, and also foreign universities almost. Because of their support, I have published more number of papers in reputed journals. Shortly, I will meet you, sir. Last time we were there offline, but I think I have not met you at that time. I think almost more than 1 year long back, I think. Some madam was principal, I think.
Dr. Kavita madam was there.
Yeah, sure.
Okay, I'll just anyways, I'll invite you one time
Sure,
for
sir.
expert sessions to our
Okay.
students and faculty members.
Okay, sir.
Thanks a lot. Thanks a lot.
Okay. Thank you for your opportunity given me to share my whatever little research I learned to the faculty members, sir. Huh?
Thank you, sir. Over to Suresh, sir.
Thank you all. I would like to thank all the participants who have joined the live session. I request all the participants to fill the feedback form for the session shared in the chat box. Please do join the next session at 11:30 a.m. on computational modeling of fluid structures interaction problem by Dr. Ranjit M. Signing off. Thank you, one and all.
Once again, thank you, sir, for Suresh, sir. So request participants kindly stay online, and the next session will start exactly at 11:30.